Hello class, today we're looking at the unit circle. The unit circle is special for us because the definition of the unit circle, it's a circle drawn on our coordinate plane, on our xy axis, and it has a radius equal to 1. So, centered at the origin, this distance from the origin to this point of intersection is 1, 0. This is 0, 1, so on and so forth. Negative 1, 0, and 0, negative 1. Okay? Now, what we can do is draw a right triangle centered at the origin. What do I mean by that? I'm going to draw a radius. I'm going to draw it this way. I'm going to stop right here. The length of this radius is 1. This is an angle. We're going to call it theta. Okay? We're going to make a right triangle. So all I have to do is just drop the altitude. Okay? And I'm going to label this point x comma y. Okay, remember from last year, when you draw an angle in standard position, this is the initial side. We always start on the positive side of the x-axis, and a positive angle we open counterclockwise. Negative angles we would go clockwise. Okay, that was all from last year. All right, now what do I have here? Well, I have lengths on this right triangle. So the distance from the origin to this spot right here is simply the x distance, the x coordinate, so x. The altitude of this right triangle from here to here is simply the y. So we have a right triangle labeled as x and y, and the radius, the hypotenuse, is equal to 1. Okay? All right, so now we're going to tie this to trigonometry. SOHCAHTOA. So I'm going to look at cosine first. Cosine of the angle is equal to, well, CA, adjacent over the hypotenuse, x over 1. Well, so that tells us that the cosine of the angle is equal to the x-coordinate as long as we are in a unit circle. So this x value right there is the cosine of that angle. Now we're going to do the same thing for sine. Sine of the angle is equal to, well, sine is opposite over hypotenuse. So there's the angle. Opposite of y, hypotenuse is 1. So y over 1. So sine of the angle is equal to the y value, the y coordinate. Okay, so now let's also try this to tangent. Tangent of the angle. Well, tangent is opposite over adjacent. Opposite over adjacent. So that's y over x. And we just picked up the y is sine of the angle and x is the cosine of the angle. This right here is our first identity, that the tangent is equal to sine over cosine. Okay? That's our first identity that ties all three of these pieces together in the unit circle, only for the unit circle. All right, another thing that we get from the unit circle is what's called the Pythagorean identity. We have 3 Pythagorean identities. We're going to pick up one today. Okay, remember the Pythagorean theorem? A squared plus b squared equals c squared. Well, in this triangle then, x squared, y squared equals 1. Well, and then we just picked up the x is equal to the cosine, that is the cosine of the angle. So cosine of theta squared plus sine of theta squared equals 1. Okay, so this is how we write, this is what this is. We don't write cosine of theta squared like this. What happens is, to make life easy for us, we write cosine squared theta plus sine squared theta equals 1. Okay, this is how we write this out. Cosine of theta, the quantity squared, we write this way. So if we wanted cosine of 30 degrees squared, we would figure out the cosine of 30, whatever that value is, and then square it. That's what this would say. Cosine squared of 30, we'd figure out the cosine of 30, and whatever that answer is, square it. So this right here is our Pythagorean identity. Okay. Now, let's do an example. Let's do a problem. Then we'll go back to some more work. Angle theta is drawn on a unit circle. The terminal side passes through P. Okay, so we're going to do two of these. So my first P value is going to be 5, 6 and square root of 11 over 6. All right, so now what do we know? We know that this is a unit circle. Okay, and this is, in a unit circle, the radius is equal to 1. And this is the coordinates of my point P. Right now, you know the cosine of angle theta, we know the sine of angle theta, and we know the tangent of angle theta. Okay. What's the cosine of angle theta? Well, a unit circle, x is equal to the cosine of theta. Well, there's your x value right there, so the cosine is 5 over 6. Sine of theta, sine is the y coordinate. Y is equal to the sine of the... So then, the sine is equal to the square root of 11 over 6. And then the tangent is sine over cosine. So, sine over cosine. So, radical 11 over 6 is over 5 over 6. And then, remember, complex fractions, we can cross out those 6's. So we have radical 11 over 5 as the tangent. Okay? Okay? My new P value. Let's do another one. My new P value, 3/5 and -4/5. Okay? We're going to do the exact same thing. What's the cosine, sine, and then the tangent? What's the cosine of the angle? What's the sine of the angle? And what's the tangent of the angle? Okay? Well, unit circle, passing through this point. Cosine is equal to, there's your cosine right there. This is your cosine, 3/5. This is your sine, -4/5. Oops. And then tangent, sine over cosine. So sine over the cosine. So -4/5 over 3/5. And then cross out those 5's because of a complex fraction. We can do that, -4/5. 2/3. Okay. By the way, what quadrant is this? This is positive cosine, negative the sine. So this is in quadrant 4. Tangents negative in quadrant 4. We're going to do that next. Okay. New sheet. All right. Now, the unit circle also tells us when our trig functions are positive or negative. Sines, positive or negative. Okay? Let's go through this. Here's quadrant 1. What are the signs in quadrant 1 when we graph this? X, Y. Well, X's are positives. All Y's are positives. What about quadrant 2? Well, your X's are negative, but your Y's are positive. Quadrant 3, both are negative. And in quadrant 4, your X's are positive, the Y's are negative. All right, now what does that do for us? Well, we just picked up on in the previous piece that when we are in a unit circle, the x-coordinate is your cosine and the y-coordinate is the sine. There we go. I'm going to put C's and S's on all of these. So right now, we know in the first quadrant, the cosine and the sine are positive. In quadrant 2, the cosine is negative, the sine is positive. Quadrant 3, they're both negative. Quadrant 4, the cosine's positive, the sine is negative. Okay. Remember tangent now. Remember tangent is sine over cosine. So that means a positive over a positive. So we know tangent, I'll put T with an arrow, is positive. Okay, here, sine over cosine. Positive over a negative, the signs are different. Tangent is negative. Negative, negative. Tangent is positive. And then over here, tangent is negative. All right, now why did I do all of this? Because what happens now is we know when the functions are positive or negative. And we have a little saying for this. A, for all are positive. Your sine, your cosine, your tangents are all positive. S is positive. The only function that is positive in quadrant 2 is the sine. Quadrant 3, what's the only function positive? T, tangent. And in quadrant 4, what's the only function that's positive? C, cosine. ASTC. The little memory device to help us to remember when the functions are positive. Okay? So you have lots of ways of memorizing that. You did that last year. All students take calculus. Okay? Why do I need to know that? When we are doing our problems, we need to know in what quadrant is the function to know if the function is positive or negative. Yes, the calculator can do that, but there will be some times where you can't use a calculator, so you need to know how to find that information. Okay? So we're going to play a little quadrant game. Name the quadrant. Okay? Sine of theta is greater than 0, and the cosine of theta is less than 0. We're going to name the quadrant. What quadrant is that? This is what I do. Draw my axes. I put little check marks. Okay? I'll do a black check mark for sine being greater than 0. Well, where is sine greater than 0? Well, A, S, T, C. All are positive, so I'm going to put a check mark here. Sine is positive. Put a check mark there. Tangent's positive, not sine. Cosine's positive, not sine. All right, now this one says cosine is less than 0. That means it's negative. So we're looking for the spots when cosine is negative, and I'll put that in a pink in my purple. So I'll do purples here. Purples, and I use the black for this. Okay. So we're looking for where cosine is negative. Well, A means all are positive. C means cosine is positive. Tangent, T means tangent's positive. Everything else is negative. So that means cosine is negative here. And sine is positive. Cosine is negative. In other words, we're looking for where is the x-coordinate negative. Well, the x-coordinate is negative on the left side of the x-axis. So these two spots. And then our double check mark, quadrant 2. So that's what you're looking for. Let's look at another one. Tangent of theta is equal to 4/5. We'll talk about that, what that means. And the sine of theta is less than 0. Again, here's my axes. I'm going to put my ASTC. All right, I'll do the black check marks for tangent, then I'll do the purple check marks for sine. Okay. Tan theta is equal to 4/5. Well, what do you know about 4/5? Well, it's positive. So I need to know where is tangent positive. Well, A is all are positive. T, tangent's positive. Okay. Sine theta less than 0. When is the y value negative? The y's are negative when we are under the x-axis. Well, negative, negative. And we have our double checks right there. So quadrant 3. We name the quadrant. Okay. Let's do one more. Cosine of theta is greater than 2/9, and tangent of theta is equal to 2/9, and the tangent of theta is equal to negative, let's do something wacky, square root of 77 over 2. Again, all you really care about is positive, negative. All right, black check mark, purple check marks. Okay. Cosine theta equal to 2/9. That's positive. So, remember, cosine of your x's. Where are the x's positive? X's are positive on the right-hand side of the y-axis. So, positive, positive. That's, remember, ASTC. Tangent is negative. Well, tangent's negative in the, remember, all are positive, tangent's positive, so we're looking at quadrant 2 and quadrant 4. And we're double check mark quadrant 4. Okay, that's name the quadrant game. You're going to see that in the homework. Okay. All right. Last piece of information that we can do. From the unit circle, I'm going to draw another unit circle. So there's another unit circle. Remember, ordered pairs, 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. Remember, we had our angle theta drawn here. We had our angle theta drawn here with our triangle. I'm not going to draw the triangle in this time because we're going to look at 4 specific angles in this piece today, and then our next lesson we'll be looking at other pieces, the other angles, our other special angles. So right now in this unit circle, we're only going to be looking at what are called the quadrantial angles. The quadrantial angles are your 0, your 90, your 180, and your 270. Okay, If you remember your radian measures, well, 0, these are all degrees. This is 0 radians. This is pi over 2. This is pi. This is 3 pi over 2. And then we go back up to here to 0, which actually becomes 2 pi. And then 0 becomes, the other thing for 0 degrees is 360. Yep, in pre-calculus, we're doing them both, degree format and radian format. Okay? So, right now, without using a calculator, you know the sine of 0, the cosine of 0, and the 0. And you know the tangent of 0. Okay? From the unit, without using a calculator, I know this. That's a 0 right there. That's not an angle. That's not theta. That's 0 degrees. Or 0 radians, the same thing. Okay? So, the sine of 0 degrees, or 0 radians, because that's where we start. Remember, here's your ordered pair. Cosine, sine. Well, the sine is 0. The cosine is 1. And then the tangent is sine over cosine, 0 over 1, which is 0. Okay. And then last one, I'm going to do 90 degrees. Actually, I'm going to call it pi over 2. So, and I'll do it right here. The sine of pi over 2, the cosine of pi over 2, and then the tangent of pi over 2. Okay. Remember, sine of pi over 2, that is 90 degrees. Remember, here is our cosine, alphabetical order, sine. Here's your cosine, sine. So you can do this on your paper. So the sine of pi over 2, sine of pi over 2, there it is, 1. Cosine is 0. And now the tangent, sine over cosine. 1 over 0, that's undefined. Okay? You're going to see a problem like this on the homework too. All right, you guys have all the info for your homework. Good luck with your homework.